Good morning, guys. Today we're going to be looking at solving absolute value. So kind of like what we were doing last lesson, but instead of having equalities, we're going to be looking at inequalities. Um, so inequalities just means when you use, and let's take a look at a couple of the symbols. But it's basically, if I slide down here, you have the the inequality symbols, the less than, greater than. So it's not necessarily that they're equal to a specific number, but they're unequal or unequal to them. So we have um, a compound statement, right? What is a compound statement? There's two types. There's a disjunction and a conjunction. A compound statement is made up of more than one inequality. So disjunction, meaning, not together. The prefix for disc is away from, and junction means, away from being together. So if you notice, there's a big gap in this number line, and the symbol for disjunction is the word or the word for disjunction is or in math terms. And so we have this disjunction because we have x is less than or equal to -2, so it's going to be shaded. We're shading everything from -2 and to below, and then over here we're shading from 5 and greater. But notice that we have closed and open. So on the -2 it's closed because of the less than or equal to. So because of the equal to, it's closed. And then where the 5 is, we have an open circle because it doesn't have equal to, right? So again, this is a disjunction. This happens when there's a gap, there's not a union there. And then we have conjunction. It uses the word and conjunction means, there is some sort of intersection between them. So again, using the same numbers, right? -2 and 5. If I'm looking at every x value that's greater than or equal to -2, I'm going to shade everything greater than -2, so to the right of -2. But it's also saying we have kind of like a maximum of 5 and anything less than 5. So we're shading anything less than 5. So it's kind of keeping us between these two values. And again, this is closed because of the inequality has an equal to, and at the 5 it's open. Okay. Let me zoom out here. Okay. This next part is talking about the absolute value. Okay, how are we going to use inequalities for the absolute value? So I can have something like the absolute value less than 2 and the absolute value greater than 2. And notice this is the graph of the absolute value. If I shade everything less than -2, so less than this line, then I'm actually going to be shading, this part of the graph. Right? Any part of the graph that's below -2, and so that's going to cover on the number line. It's going to cover from here, and actually let me do an open circle. It's going to cover this much. Okay, and I'm doing an open circle again because we have, this means open, right? Open. Now, the other thing is, what about the other side, the right side, the greater than? Okay, greater than means everything that's greater than 2, again, it's going to be open because of this symbol. It's open. And greater than 2, that's going to cover this part of the graph. Right? But if it's only that part of the graph here, what is that as far as the domain goes, the x values? So it's going to go open here, and I'm going to shade this way, and then open at positive 2, and then shading everything over here. Okay, so this is what this means graphically. So I have two solutions here. I have, two solutions. Over here would be x greater than negative 2 and x less than 2. Right? And then over here on the other one, I have, and there's an and here, word and. And then on the other one over here, I have x less than negative 2 or x greater than 2. Okay, so these are the two statements right here. You know, x greater than negative 2 and x less than 2 covers this space, and x less than negative 2 and greater than 2 covers this space. And basically on the right side of this page, or on the other page, if I scroll over, then we have the following. So we have basically two cases that we're interested in when looking at inequalities. And then after that, I'm going to talk about two special cases down here. But the two cases are, either I'm going to have an absolute value that's less than a number or greater than a number. If it's less than a number, so I'm going to use a color here. If it's less than a number, and let me use a different color to make it distinguishable. Let me use a brighter color. So if I have less than, then I'm going to focus on having an inequality that looks like this. This is called a compound inequality. And so basically you're working with something that's you're looking between two numbers. So this is just basically saying that you're looking between the numbers negative 2 and 2. But notice that you have to have the less than symbol twice here. So if I'm looking between two numbers, it's because I have a less than symbol. Okay. The other situation is if I have a greater than symbol. If I have a greater than symbol, then I'm looking at everything greater than 2, but also less than negative 2. So I'm looking at everything greater than 2 and less than negative 2. So that causes this big gap here. But what's gonna happen in our solving methods is we're gonna have to do kind of like solve two problems separately. And this is what we were kind of doing last class, where we would have to do 2 problems separately, and we would get 2 answers, right? So the new thing for today is when I have less than a positive number, if it's less than a positive number, then I'm going to do kind of this compound inequality. If it's greater than a positive number, then I'm going to do two separate calculations. Okay, and then we have 2 special cases. So let me zoom out. Two special cases here. All right, the special cases are when I have negative numbers. Okay, so let me change the color here. So I have a special case when I have less than a negative number. If I have less than a negative number, then what's my answer going to be? No solution. Okay, why is it no solution? The absolute value is always positive or 0. Right? Anything you put in the absolute always becomes positive, or if it's 0, it's 0. So it cannot be less than a negative number. So this is a false statement. And so the last situation, and I'll use purple just to kind of mix up the colors. If I have greater than a negative number, then my answer is all real numbers. Because it's saying what numbers are, the absolute value is always positive again. So it's always going to be greater than a negative number. So no matter what you pick as an x, this statement's always going to be true. So this statement is always true. And this one on the left is always false. Okay, so these are 4 cases if you want to think of it this way. Okay, so but they all kind of surround the same idea. I have less than, greater than, greater than. What's the difference, right? Because I have less than over here, I have less than over here, I have greater than over here, and greater than over here. What's the difference between these 2 less thans? One of them is less than a positive number, the other one is less than a negative number. So we got to look out for these. And then there's 2 greater than situations. One if it's greater than a positive number, and one if it's greater than a negative number. Okay, and we're gonna look at examples of these 4 cases just to get an idea. Okay, and the last thing here, let's take a look at the steps here, the rules. So steps for solving absolute value inequalities. First, isolate the absolute value. Isolate the absolute value expression. Rewrite the absolute value as a compound inequality. So with no absolute value bars. Solve each part of the compound inequality for x. Let's highlight some keywords here, right? So some keywords: isolate. That means, what do we want to isolate? The absolute value expression. So anything that has, the absolute value bars. Then we want to rewrite into a compound inequality with no absolute value bars. No absolute value bars. And the last thing we want, the third thing is we want to do is solve for what? Solve for x. And then the last thing we're going to do is graph the answers. So get the absolute value by itself, isolate the absolute value, rewrite into a compound inequality, solve for x, and then graph the solutions. Okay, so let's try it out. Let's try this out. So example 1, look at the instructions. Solve each absolute value inequality, then graph the solutions on the number line. Show all your work. Great. So the first step is isolate the absolute value. Isolate the absolute value, but it's already isolated. Is it not? It's already, the bars are already by themselves. So the next thing we look for is, do we have a greater than a positive number or greater than a negative number? Or is this a less than? This is what we have to remember. Is this what type of symbol is this? So if we break it down, we have, let me choose this color. We have greater than, a positive number. All right, so that means we have an OR situation, and so what we have to do is rewrite the equation. So I'm going to copy 6x minus 9. We're going to rewrite the equation without the absolute values. So 6x minus 9. And so we're going to have two situations. Either we have less than or equal to negative 27 or 6x minus 9. Copy the equation. Greater than or equal to positive 27. Okay, and I'm just following the idea of the previous page, on the previous page. So I have two problems to solve, and let's solve for x. So let's work with this one first. Solving for x, the opposite of subtracting 9 is adding 9. And so here the 9s are going to cancel. It's going to leave me with 6x less than or equal to negative 18. And then we're going to, opposite of multiplying times 6 is dividing by 6. These cancel. X is less than or equal to negative 3. So that's one answer. And then we got to go check the other side. And it's basically the same steps. We're going to do plus 9, plus 9. These are going to cancel. Bring down the 6x greater than or equal to. Actually, let me fix this symbol. It's bothering me. There we go. Okay. But this time, look at the difference between my two situations here. Here I have negative 27 plus 9. Here I have positive 27 plus 9. So positive 27 plus 9 is going to be positive 36. But I'm also going to divide by 6, because the opposite of multiplying is dividing. And so my other answer is x greater than or equal to 36 divided by 6 is 6. Okay, so now that I have these two answers, now I'm going to graph them. So let me zoom out so that we can see the number line. There we go. Okay, so if I have 0 in the center here, and let's see, I'm going to do, how am I going to space this? Just do 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. -1, -2, -3, -4, -5, -6, -7. Okay, so now I want to shade my answers. Notice that it's equal to and it's at -3. So -3 is right there, so closed circle. And then less than -3, so I'm going to shade everything less than, even putting an arrow that way. Okay, and then the other number is at +6. It's a closed circle because of the equal to, and I'm going to shade everything greater than with an arrow. Okay, so that's my solution there. Okay, and this is, again, this is a greater than a positive situation. Greater than a positive. All right, let's go to example 2. And again, let me zoom in so that we're solving. There we go. Yes. Okay, the next one. Step 1, get the absolute value by itself. So I have the absolute values right here and right here. Is it by itself? No, right? There's a 5 next to it. So the opposite of multiplying times 5 is dividing. So it's going to cancel this one and this one. Then we end up with the absolute value of 2x plus 6 less than or equal to 80 divided by 5, 16. Okay, now is the absolute value by itself? Yes. This symbol is less than, and the 16 is a positive number. 16 is positive. So we have a different situation here. Okay, this is how we're going to work with this situation. If I have less than, then we're going to set it up like this. We're going to say, I'm going to copy the problem without, I'm going to copy the problem without the absolute values. And then on the left side over here, I'm going to do the compound inequality. So I'm going to put another less than symbol, and this time I'm going to put -16. Okay, and then this one we're going to kind of get two answers, but by carrying the steps all over these 3 sections, because it's 1, 2, 3 sections. So if I want to get x by itself, right, I need to get rid of the +6. So the opposite of adding 6 is subtracting 6. But I'm going to subtract 6 on 3 sections. So subtracting 6 here, and I'm going to subtract 6 with the 16 here, and I'm going to subtract 6 with the negative 16. So I'm going to subtract in 3 different sections. So over here, what do I get? Let me put a line underneath just so you can see. What do I get when I subtract negative 16 minus 6? That's negative 22 less than, bring down the 2x. The positive 6 and the negative 6 cancel. Bring down the less than symbol. And then what's 16 minus 6? It's 10. Okay, again, I want to get x by itself. So what's the opposite of multiplying times 2? Dividing by 2. But I'm going to divide everything by 2. So on the left here, what's negative 22 divided by 2? That's going to give me a negative 11. Bring down the less than. The 2's cancel, which leaves me with an x. Bring down the less than. And then 10 divided by 2, 5. So this is my answer. Okay, and when I have an answer like this, we have less than. This number right here is like my minimum, and this other number here is like my maximum. Okay, so let's do the number line. I'm trying to decide how I want to do it because I want to fit 11, but I don't think I'm going to fit it. So let's say again this is 0 right in the center, and here I'm just gonna measure. So measure in this way. So if I'm gonna do by 2's, do 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10. So here I have 2, 4, 6, 8, 10. And then I have negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. Okay. So where is 11? Or negative 11 is going to be about right here, right? So it's going to be an open circle. Open circle. And then 5 is over here. There's a 5 there, right? And so it's 2 open circles. And again, I said this is my minimum, this is my max. So I'm going to shade everything in between these 2 numbers. So I'm going to shade everything in between these 2 numbers. Okay, and that's my answer. Okay, so it's negative 11, right? Is between negative 12 and negative 10, and 5 is in between 4 and 6. Right. Okay, so that's example number 2. Now let's look at example number 3. So let's make sure that the absolute value is by itself. So here we have the absolute value. It's not by itself, so we need to make sure it is by itself. So we got to solve, move a couple of things. Plus 5, plus 5. These cancel here. Bring down the negative 8. Then I have the absolute value of 2x minus 9. Close the absolute value. Then greater than or equal to negative 72. Then we got to get rid of the negative 8, right? What's the opposite of multiplication? It's division. So we're going to divide negative 8 on both sides. And that's going to cancel the negative 8 here. And there's something else that happens. I'll explain right now. It's 2x minus 9. Absolute value. There's something that happens when you divide a negative number with an inequality. It switches the direction of the inequality. So it'll change from greater than to less than. So again, this switches when we divide by a negative number. And so negative divided by negative gives me a positive. 72 divided by 8 is going to give me a positive 9. So now we have a less than situation. And it's a positive. So then this is just like example 2. So what we did in example 2, we copied the equation 2x minus 9 without the absolute values is less than or equal to 9. And then, so I just copied this equation from over here without the absolute values. And then I'm going to add a less than or equal to with a negative 9. And then in the middle, in the section in the middle, I'm going to solve for x. So how do I get x by itself? What's the opposite of subtracting 9? Adding 9. So I'm going to add 9 everywhere. So what's negative 9 plus 9? It's going to give me 0. Less than or equal to, bring down the 2x. Negative 9 and positive 9 will cancel. Bring down the less than or the equal. And then what's 9 plus 9? It's 18. And then the last thing, remember, I want to get x by itself. So what's the opposite of multiplying by x? The opposite of multiplying by 2 is dividing by 2. So I'm going to divide everything by 2. 0 divided by 2, 0. 2 divided by 2 will cancel. X less than or equal to 18 divided by 2 is 9. So I have less than or equal to, so it's closed. Closed circle. And this is going to be like my minimum, and this is going to be like my maximum. So if 0 is right here, and then I have 1, 2, 3, 4, 5, 6. So let's say I go by 2, 2, 4, 6, 8, 10, 12. So a 9 is right here. And over here, let's say I have 1, 2, -2, -4, -6, -8, -10. And so 0 is right here. And again, they're closed dots because of the equal to. So it's 2 closed dots. And then I have minimum and maximum, and I'm going to shade everything in between. Okay. Shading everything in between. And there, I'm done with example 3. Example 4. Again, I want to get the absolute value section by itself, but I notice that it's being divided by 8. So what's the opposite of dividing? It's the opposite of dividing by 8. Multiplying by 8. So I'm going to multiply 8 over here, multiply 8 over here. This 8 and this 8 will cancel. That'll leave me with the absolute value of 4x plus 1 greater than -8. And then I have, the absolute value is by itself. And I have greater than symbol. Right, this is a greater than symbol. But here's the twist, right? I have a negative. It's equal to a negative number. So in this case, this is one of those situations where it's all true. What I mean by all true is that this response is always true. So my answer is all real numbers. That's my answer. And so when it's all real numbers, if I have my number line here, 0 to -infinity and infinity. And so when it's all real numbers, my answer is I'm going to shade the whole number line. So if all real numbers is my answer, then my answer is from -infinity to +infinity. Okay. And again, this happens when we have a greater than symbol, and it's greater than a negative number. Okay. And so this brings me to the last one. Number 5. Again, we want to get the absolute value by itself. So the opposite of subtracting 9 is adding 9. These will cancel. I'm going to be left with 2 times the absolute value, 3x minus 8 is less than or equal to negative 61 plus 9 is 52. Negative 52. And then I want to divide both sides by 2 to get rid of that 2. And that's going to leave me with 3x minus 8 with the absolute value less than or equal to negative 26. So this is a situation where I have less than a negative number. So this is another special case, but this is the case where it's false, because I can't have, everything that I put in an absolute is going to come out positive. So I can never have a positive number be less than a negative number. So in this case, there's no solution. Okay, there's no solution, and so my number line, there's nothing to shade. There's no solution, so nothing is shaded. So nothing is shaded on the number line. All right, so that brings us to the end of today's lesson. Again, if you guys have questions, or if you want to go over a specific example in class, just let me know, and we can do that. Thank you for joining me today. Have a great rest of your day.